Hello there. It's cold outside. Well, it is winter. But it gives me an opportunity to stay inside and tinker. A couple of you have asked about block detection. What is that you keep talking about? Well, let me try and show you. My electronics background often makes assumptions that, well, everybody knows what that is. And I realize it can be a little complicated. But let's have a look. So then I've got a few bits and pieces here. We'll just go through them. 9-volt battery. You might have noticed there are a whole pile of them up at the workbench. That's because one of the controllers I use for the layout uses 9-volt batteries, but it only uses them about halfway down. Don't know if this one works, we'll find out. Useful little tip for you. Most of you will know this. DC loco. If I just put a battery in between the tracks and turn it, the loco will go along. And if I turn the battery the other way, it'll come back again. So whilst they're 12 volt nominally, they do run quite nicely on a 9-volt battery. So there's, we'll use that in a minute. This is just a piece of test track. There is a join in it there, which I will meddle with later. Right, let me just set a couple of things up here. Now then, all I've done is connected a battery connector to that battery, extended the wires a little bit. I'm just going to join a light bulb onto the end of that one. I'm just going to join these together. There we go, that's good enough for now. Now, one of the things with electrical work, it starts to look complicated very, very fast. It just isn't. There's a red wire attached to the battery. There it is. And there's a red wire attached to this LED. There's a resistor hiding in there so that the 9-volt battery there doesn't burn the LED out. If I join the two red wires together and keep your light bulb in view, it will light up. Now, with that in mind, what I'm going to do is use, do you remember these cables I used on the fence the other day? I'm just going to use these to connect from those wires to the track. But first, ooh, that hurt. I'm going to break one of the rails. So, do you remember I told you there's a join in the rails there? All I'm going to do is take one of those fish plates out. Now, as Blue Peter said, here's one I prepared for before. I just noticed there wasn't a fish plate on the other end. It's an old piece of track. So we'll just put it together like this. So there is a gap there. Now, typically, in real life, we would put an insulated pack in there. In model railway world, we put plastic fish plates, or in my case, very often just leave the gap. So now, with our battery again, if I jam another battery in between the rails, nothing is going to happen because of that gap. But if I join that gap, like this, he says, the train takes off. So there is an electrical gap. So the current can't flow because of that gap. Now then, so what's all this got to do with block detection? Well, let me show you. For the purpose of this exercise, we're going to call this one block and this another block. And because I'm interested in all kinds of trains, I thought you might like to see these. These were on the desk a minute ago. I picked these up in a Christmas market years ago when I was in Germany. Now they're made by Marklin in Germany. I've often wondered what that hole there's for. I have a feeling it's for a light bulb or something, or perhaps a connector. Now the thing about these particular models is that whilst they look lovely, they do not run on my layout, and that's because they've got axles that are very much more like the real thing, and I'll show you what I mean. Now then, over here, what we're going to do is simply join these wires, making sure you can see what I'm up to. The red wire coming from the battery, there it is, look. I'm joining to this white crocodile clip, and then the other end of that I will connect down here to one of the rails. And then the black one, you remember the black one is connected via our instant magic joint through the LED and the resistor to the red wire. Now there's not much of a wire on that, and I've got a yellow cable. I don't have a red one, so I'm going to hook up the red cable to the yellow alligator clip, and then what I will do is hold the light here and show you that when I connect this clip to that rail, that light should light up. Do you see? But if I put it to that rail, of course it doesn't. And that's because there is no electrical connection between the two. Now, if I were to take another clip and oops, this one's come out of its case. That's because I was holding fences with it. Yeah, you see, you always get the bloopers as well, don't you? Oh, I see what's going on. That jammed in my finger. Where were we? Oh, yes. If I connect so now what we've got is the red connection from the battery going to this rail and another connection there. Now, if I were to join those two rails together with this cable, so this one simply goes to another yellow one, goes from there to there. Every time I do, the light will light up. It's just I'm using the rails as a piece of wire. Right, there's our setup. I'm going to hold our light up here so that we can see it while we're fooling around. Right now, so here comes our train, and as it crosses over that join there, from this block to that block, the light goes on. Now it's a bit flickery because the wheels are dirty, and in it goes. So now the light is on because it is a block detector. It has, it tells the signalman, ooh, there's a train in that section, don't send another one. Now when that train leaves, without dragging the wires out, when that train leaves, whoop, out goes the light. Alrighty, let me just show you that one more time. Right down here, you should just be able to see that is the break in the track. And as the train leaves, the light goes out. It didn't. And this is why block detection is important. The reason it didn't is that back here, it's left one of the carriages behind. But if we have a, ooh, wait for me, wait for me, wait for me, as it goes out of the block and crosses the gap, out goes the light. So that's basic block detection. Now, The reason this doesn't work with model railways particularly well, especially when we're using more modern locomotives and so on, is because what we do in modeling is we take power from this wheel and this wheel into this wheel and this wheel from the two rails to drive the train. So if we're doing that, it gets a little bit more complicated to detect current. Now, I was going to set up a way of showing you how to do that, but nobody's ever going to use it. You can have a separate circuit that's isolated and all that good stuff. Let me just very quickly show you what block detection looks like in reality on a model railway. Right, well, you're familiar with this setup by now. Let me see if I can find the block connections. I think that's one of them there. Yeah, there's a break in the rail there. That's a plastic rail connector, and one side of it there is a wire soldered onto the track. And somewhere else, I think it's just, no, it's not. It could be anywhere within the block, which runs that way, the full length of that train. So that's the block. Ah, here it is. And so another plastic insulator. This is the block, and this is the next section. So between there and the one I showed you up there, the only feed to that track comes there. So if in that cable, for example, we were to add a little light bulb or something, or a relay, we would be able to detect that block. Now I'll show you what the circuit looks like. So underneath the layout, there we are. That's the same place. We've just gone down here. Those cables all run along here and down here, and then are broken out there and then come back up, and they go through this whole mess. Now, it doesn't matter how all of that works. This is just my method of connecting to this device. And this is the gubbins, the electronic bits and pieces behind block detection. These two cables here are what we refer to as LocoNet. Loco in Spanish meaning crazy, and it's appropriate. But these run off, one of them runs off to the next one of these, and the other one runs to the computer. So that's what we've got going on. That's what it looks like. I am not going to attempt to explain how all of that works, don't worry. Now, back to our magic light that comes on every time a train goes in to the section or not. If you changed that light for a red light and put it in a signal housing, you have the basis of how a danger signal works on a real railway. So how would we get a green light to go out? Well, the way it's actually done is with a little relay, which is a electronic switch that switches from one to the other. But you could also do it by just shorting the connection to the light out. So when the train came into the section, it would join the two wires together and the light would go out. Now, I've never actually done that, but since I mentioned it, let's give it a try. So let's move the track along. Here comes a train into the section, and out goes the light because it has joined the two rails together. That would be fail-safe. So if the light goes out, something's wrong. Either there's a train in it or the bulb has blown. Otherwise, the bulb could blow and you'd think, oh, yeah, it's fine. So all I did to simulate that was rewired the connections a little bit. You don't need to worry about how. Now then, while we're at it, I've been hunting everywhere for this particular box, and in here, it's all the leftover electronic parts. There's I knew I had some somewhere. Magnetic reed switches. I've just ordered a whole pile of new ones of those, so they're in there. Good to know I actually wasn't losing my mind. Some IC holders. A couple of relays. That's what a relay looks like. Some more resistors. A few LEDs hiding in here. Ah, this is what I'm looking for. Diodes. Let me just pull up one of these. I know what they are. And close the lid and seal it before I end up with electronic components from here to kingdom come. Right, put that there, put this away. Well, this thing is a diode. I don't know if you can see. Let's use the light emitting diode to light it up. So the LED light emitting diode is simply a diode that when it's conducting, it gives off light. This one doesn't give off light. If it does, you've done something wrong. On that end, you see that silver stripe? I don't know if you can or not, but there's a stripe on that end. That's the plus end. So plus and minus. So this thing will only, we can argue about this all day, but it will only let electricity go from there to there. You can argue that. Don't. Since I've got a track with a gap in it and some crocodile clips, I thought I'd show you how automatic stops and reversing thingies work. Right, let's move these carriages out of the way. These have got some interesting couplers, by the way. Have you seen those? Much more interesting. So now, for the purpose of this exercise, we are going to clip the white one all the way down there so that the train can run. Leave it here. And the yellow one, well, I better show you so you know what I'm doing. Yellow one all the way down here. That battery is no longer in use. Let's pop it over there. Right, so we've simply got a wire hooked either side of that gap. In real life, we would simply, in modeling life, we would simply solder that across the gap. But I'm just going to hook it between these cables. So electrically, all I've done is hooked that diode across that gap. So let's put our locomotive on the track. Now I have a 50-50 chance of having got this right. All I'm doing is putting the battery back between the tracks. Let's turn you a bit so you can see me do it. There we go. Battery between the tracks, and the locomotive comes towards me. If I reverse the battery, turn it the other way, the locomotive will go that way. Oh, but it stopped. It stopped because it's crossed that gap. There's a break in the rail there, remember? So how did it come this way before? Well, across the gap is that diode. Only lets electricity pass one way. When I reverse the battery, here comes the locomotive again. So that's the principle of an automatic reversing loop or section. A couple of things you can do with that are kind of interesting. The first is you can use it, so if you put a switch there, let me get this thing the right way around, and I will simulate a switch by jamming a screwdriver in the gap. Is this going to work? It might. So you put a switch across there, the train will continue to run. When you you open the switch, it stops. Can you see those uses? So simply, my screwdriver is the switch in this instance. So this is how automated stop works in a DC circuit. Now, I was going to talk about DCC and DC today. I'll save that for another day. Now, ooh, it's cold down here today. DCC and DC all plays into this because some of the tricks we use with DC control, which is what we've been doing today, don't work when we get to the DCC world. I'm not going to go on, don't worry. But with this shuttle that we've just created, if you had a longer track with a gap like that at each end with a diode like that across it, then every time, whoops, the wrong way, every time the controller switched polarity, in our case simulated by turning a battery back and forth, the locomotive would run from one end to the other and stop. So all you have to do then is come up with a circuit that flips the polarity of the DC supply back and forth. It ends up being a black box. This really is one that is in use. 2 wires going off to the track, power supply coming in. Don't know what the other two are for. They do something kind of fun. No idea what. But that simply runs my tramway, which has a diode there. Let's see if we can see it. There's the gap, and the diode is buried in the plaster there. This doesn't work, not because there's anything wrong with the electrics, but because, like a numpty, I put too much plaster. You can see where the trams scrape on it. And plaster just isn't a good thing to use around model railways. We'll get a shuttle working and show you how we built it. But for today, here endeth the first lesson in electronics. I kept it really simple because I know there's plenty of channels out there that will teach you all kinds of clever stuff. If you've got specific questions, that was my area of kind of expertise, but shh, don't tell anybody. Couple of comments on DCC. We will get into that one day. DCC is immensely more difficult to set up in the first place. I've done both. But the bigger you get, the bigger layout you have, the more complicated the layout is to operate without it. You can operate a layout perfectly well with DC, and you can operate a layout perfectly well with DCC too. You saw me struggling remembering, I think in yesterday's video, a couple of days ago anyway, I was showing you the automated thing I've got with the computer hooked up. It's just that the computer does all of the nitty-gritty stuff, the point changing, remembering which locomotive's which, preventing them from crashing into each other. So DCC, once it's set up, is rather lovely. But getting it set up, ooh, now that can be a game. Thanks for watching. We'll see you again in the next one.